Namaste and hello to all of you. I am 𝐃𝐞𝐿 and today we are going to continue with a new video in which we solve the rest of the departure sums or distances on Earth sums from R.K. Bali chapter. You already know the importance of these questions. I also suggest you all to do the questions from Oxford departure chapter and Keith Williams questions. Subscribe to this channel beforehand so that you get timely updates as and when I upload new videos containing departure questions. Knowing these questions, solving them, knowing how to solve them, it will guarantee you full marks on all the departure questions for your CPL written exams, ATPL exams, and airline entrance exam. So all the best. Let's start with today's questions. Question 1 for today, which is question 43. Aircraft is departing from point A, flies a constant through track of 270 at a speed of 120. What are the coordinates of the position after 6 hours? So what is the final position after 6 hours duration? So now it's flying a track of 270. This indicates that it is flying a track of a rumline track. So let's draw this. Okay, this is your prime meridian. Okay, so you are at 40° north, 80° east. So this is your 080 east longitude, and you are at 40° north. So both locations will be on the same latitude because it is flying a fixed direction of 270, which means it is flying a rumline track. And all latitudes are rumlines, therefore the location of initial, that is your departure, and whatever your destination might be will be the same. So 40 north, 80 east is initial location. Speed is given, time is given. Let's find distance. Distance equals to speed into time. 120 into 6. So distance will be equal to 120 into 6, 720 nautical miles. The distance is 720 nautical miles. This distance is your rumline distance. And over here, let's plot this here, 80° east. So 80 degrees will be somewhere here, 080 east. And you are flying a 270 direction. That means you are flying a clockwise direction. So clockwise means from 80 east, you are traveling in a direction of clockwise. So you can either be between 0° meridian and 80° east longitude, anywhere between these two, or you can enter western hemisphere altogether. That is also the second possibility. So let's do this. Our distance is 720. So rumline distance is d long in minutes into cos of lat. 720 is d long in minutes into cos of 40°. So d long in minutes equals 720 divided by cos 40. 720 divided by cos 40 is 0.76. So d long in minutes is 939.8. So approximately 940 minutes, or convert that into degrees, divide by 60. 15° 39 minutes or 15° 40 minutes. Okay, so that is the d long, the difference between initial longitude and final longitude. So now we know we are currently at 80 east. Going westerly direction, which is clockwise direction, our longitudinal value will decrease, and therefore new longitude will be what? It will be initial longitude, the starting longitude, minus d long, minus d long. So initial is 080, d long is how much? 15 degree 40 west. So 080 degree minus 15 degree 40 minutes, it amounts to 64 degree 20 minutes east. So new longitude is 64 degree 20 minutes east. So yeah, somewhere here 64 degree 20 minutes east. Simple. So focus on your initial position, focus on the direction you are flying, then the distance. Now here the distance was not given to you directly, so you calculated using speed into time formula. Use drumline distance and get the new longitude. To find or to know whether your new longitude will be A, B and C are given to you, we have to find distances between AB and AC. So let's plot that. Very simple. So position A is 60 north, 20 west. Position B is 60 north, 21 west. Position C is 59 north, 20 west. Now let's find distance between AC first. Now AC is a great circle distance, right? AC is a great circle distance since both are located on same longitude but different latitudes. So distance AC equals to great circle distance equals to d lat in degree into 60. Difference in latitude is how much? 60 minus 59, 1 degree, which is multiplied by 60 is 60 nautical miles. Great circle distance is 60 nautical miles. Distance AB is how much? Distance AB is your rumline distance. So rumline distance will be equal to d log in minutes into cos lat. D long is how much? 20 west and 21 west. 1 degree into 60 into cos of 60. So 60 into cos 60 is half. So that is 30 nautical mile. So what is the correct answer? A, B. A to B is 30 and A to C is 60. So correct option is option Charlie. Let's go to question 45. Aircraft is at latitude 10 north and flies 180 at a speed of 445 km per hour for a duration of 3 hours. So speed is given, time is given, distance will be speed into time, 445 into 3. 445 into 3 is equal to 1335 kilometers or 722 nautical miles, right? So this will be a great circle distance. Now let's draw the earth. Okay, we already have that. So equator is 0 degree. We are currently situated at a latitude of 10 degree north, right? We are at 10 degree north, and from here we are flying a 180 heading. We are flying a heading of 180. So there are two possibilities now. Initial latitude is 10 degree north. Our final latitude can be in southern hemisphere or it can be in the same hemisphere, that is north hemisphere. To know that, we will have to find difference in two latitudes, d lat. So now d lat is how much? D lat equals to your great circle distance, d lat in degree into 60. So 722 d lat in degrees into 60. D lat is 722 divided by 60, which is equal to 12 degree 2 minutes. So now check this. Initial latitude is 10 degree north. The difference between 10 degree north and 0 degrees how much when we travel south? It is 10 degree. But our total d lat is how much? It is 12 degree 2 minutes. 12 degree 2 minutes. So out of this 12 degree 2 minutes, we travel 10 degree in the north hemisphere. Remaining 2 degree 2 minutes will be traveled in the southern hemisphere. So our new latitude will be 2 degree 2 minutes south. 2 degree 2 minutes south. Option B will be the correct option. Okay. So simple, find distance, which will be your great circle distance. After finding that, draw the earth, label it. After that, you will get a general idea whether your new latitude is going to be in the same hemisphere or a new hemisphere, and therefore new latitude is 2 degree 2 minutes south. Question 46. We are at latitude 10 degrees south. We are flying north at a speed of 890 km per hour and duration is 1.5 hours. What will be the new latitude? Same like previous question, similar. So let's find distance. Distance is 890 speed into time 1.5. 890 into 1.5 is 1335 kilometer. That is 722 nautical miles. Now we are at 10 degrees south. And we are flying northerly direction. So our new latitude can be in the southern hemisphere itself, or it can be altogether in the northern hemisphere. So what is d lat between 0 degree equator and 10 degrees south? It is 10 degree. Now let's find the d lat for this question. So d lat is equal to 722 into 60. D lat 722 by 60. 12 degree 2 minutes. 12 degree 2 minutes. So out of total 12 degree 2 minutes, 10 degree was spent or traveled in the southern hemisphere. Now what is remaining? Only 2 degree 2 minutes is remaining. 2 degree 2 minutes is remaining. So 2 degree 2 minutes, 2 degree 2 degree 2 minutes will be traveled in the northern hemisphere. So new latitude will be 2 degree 2 minutes north. 2 degree 2 minutes north. 12 degree 2 minutes was the total latitude difference. 10 degree here, remaining 2 degree 2 minutes in the northern hemisphere. So what will be your new latitude? New latitude will be option A. Option number A. Okay, 2 degree 2 minutes or approximately 2 degree north. So this is how you solve all the questions. I hope you have understood this lecture very well. If you have liked this lecture, do hit the like button. Subscribe to this channel. Let me know your comments, questions, feedback in the comment box. Check the description box that I have given. I will put the links to other videos, especially the link for Oxford General Navigation Departure chapter. I have solved all the questions with detailed explanation. Also watch that video. And do share this video with all your friends.